Thank you for that introduction. And thank you everybody for joining us this morning. I do want to say a final thank you to Steve Ducker and the KHL team for putting this together. Steve, we're going to miss you going forward, and good luck in your future endeavors. So I'm with Brandenburg Industrial Service Company. We were started in 1968. We traditionally rank in the top 5 as far as size goes. Not that important to us. More important to us is our client relationships. As Luan and Pierre and Alexander spoke about this morning, that client relationship is really what carries us forward. We stay in the range of about $300 million per year, give or take. Like I said, 800 employees. Started in 1968 and grown organically, so no acquisitions. I'm here to present the Tennessee Valley Authority Johnsonville plant in New Johnsonville, Tennessee. The building, or the power plant itself started in 1951, finished in 1959. As you can see from this overhead picture, back here. Sorry, looking for the laser pointer. These first 4 units here, those were the initial 4 units built, and that was to feed the Chemours plant, which is on the same property, but kind of over here in the corner, which was kind of important, and we'll talk about that a little bit later as far as utilities are concerned. The final 6 units, you can see the white ones next to it, bring a total of 10 units, roughly about 1,400 megawatt capacity. It's shut down in 2017, and TVA does a very good job, and similar to EDF in terms of onboarding their contractors. It truly is a partnership, and they're very much embedded in what you do, and I'll get into that a little bit more as we go forward. So a typical scope of work, environmentally, obviously, waterway next door, the coal unloaders, we have the conveyor work here, this was their coal yard. Mooring cells did remain, but the sluice lines, the walkways, we were responsible for taking that down, or taking those off. All the regulated materials, the coal and ash, you have to wash down for them as well. T-norm, any of the technologically enhanced, normally occurring radioactive material. So we have to monitor for that, for any of our scrap that goes out. SUMP's operations are very concerned about the waterways, obviously, so that's a very important factor to take into consideration. Demolition scope of work, typical again for TVA, 3 feet below grade. All the structures come down. What you can see, and you start to see some of the challenge in this project in particular, you got a little bit of a bottleneck here, but this switch yard remained, stayed live. They had to have access to it. This is a water treatment facility that helps out, and Chemours relies on that, so this has to stay not only in operation, but has to stay accessible for the workers to get to as well. On this side here, you'll see this road kind of led to an island, and they were doing some work out there. So this access had to stay maintained as well. So you can start to see some of the challenges that we're going to have to decide upon and address as we go forward planning a project of this magnitude. So overhead, this is a nice overhead view. So you can see the blue is our boundaries. That's our project boundaries. And so our egress in and out of the site is right here. Again, this switch yard remains. Water treatment over here remains, you'll see that. Anything highlighted in pink, for TVA, that's a specialized plan. So there's engineering, and there's plans that have to go in that they need to approve. So anything with an engineered plan also has a training module. So as you hand in your plan, write your plan, get your plan approved, which could be multiple iterations of that. I'll give you an example. We're in our 4th plant in a row for them now. We handed in our HASP, which you would think, after 4 times of doing this, and handing in a very similar document, we received that back. I believe we had 52 comments in our first draft. So we had to rewrite as much of that and address all of their comments. Contractually, they have 2 weeks to return that to you. And I say all that because it's really important when you make the decisions, when you hand in your plans, and once you get all that approved, do your training module, your schedule can be severely impacted if you aren't on top of those plans and submitting those plans. So we come to what I consider to be the inflection point of the job, right? So now we got the job, we know our asbestos scope, we know our environmental scope, we know our demolition scope. we have to make decisions right now that are going to set you up for either a smooth sailing route with minimal adjustments as you go, or you're going to constantly be changing and adjusting. And again, for this particular client, any changes, they're not frowned upon, but again, it will be a new plan. You must amend your plan, it's got to get approved. So you're making decisions now that anticipating where you're going to be, where you're preparing scrap, where you're setting up your crusher 18 months from now. And if you don't do that well, then you will be moving those things around, you'll be handling material more times, obviously upping your cost. So our access and egress, we need to determine that. Where are we going to set up the scale? The scale also has to have the Micron meter, so we're testing for that T norm as things leave the site. Where's our facilities? You know, we have up to 150 guys on site when we were doing the abatement. So where are you having your safety meetings? You need to accommodate that many. Where's your lunchroom facilities? So there's a lot that goes into that. One of the things we talked about here, and going back, and addressing that bottleneck right here. So you could see, we know at some point we want to make a ramp into the basement. We're going to have to empty the basement. So here's where we're deciding our means and methods. How are we going to bring this down? Are we going to take it down in stages? Are we going to do 2 boilers at a time? Are we going to do the original 4, then the other 6, so we can process material while we're also doing the demo? Are we going to do all the abatement first and do the demo in one shot? Are we going to take out this stack so we have more operating area here? Obviously, you can't take a ramp out of the building this way. You'll be in the water. So we know the ramp's going to have to be over here on this side to have egress into and out of the basement. We're going to have, where do you want your scrap processing facility? Well, you don't want to move the scrap very far. You want to have it as close as you can. So it's going to be over here in this area. We know that. Can we take this stack first? Well, we can. We kind of walked down that road with TVA. We were going to drop the stack into the coal yard. Problem being, live utilities right here on this side of the stack. Come to find out, TVA may think prior to award, we think a little after the award. But these utilities, Chemours is going to have an outage for 24 hours, so we could drop the stack, have people there to address those utilities if something were to happen. Liquidated damages on shutting down Chemours for 1 day was $1 million. So we decided to leave the stack till the end. So what we decided was to start our abatement, start on all the outbuildings, at some point start the demo so we could catch up to the asbestos removal, but not too early so we don't have a crew sitting there waiting. So we wanted to start our abatement, work from the outside in, all the way into the power block itself, concentrating on the turbine hall first and finishing the boilers last. There were a few challenges with the abatement. I guess I'm skipping ahead a little bit here. So back to our inflection point in making all those decisions. Knowing your client, right? Your client expectations was very important in this project. So again, just a quick shot of the training plans. This is our project folder. So these are some of the plans, and as you can see, some of the plans, you'll have phase 1, phase 2, phase 3. So all of these had to be written plans, and some of these also had to have training modules. So training modules, again, you're just training your entire field crew on operation of that plan. So we also had to have a training matrix. So each employee was entered into this training matrix, and you kept track of every one of these. On 3 of the 4 projects we performed for TVA, because they're a government entity, we had the Inspector General come in and do an audit. And part of what they audit is exactly this, your training matrix. So now we know our environmental scope, we know our demolition scope, so now we can actually mobilize to the site. Again, making sure your site orientation plan is approved and your training module is approved, because that's the first thing you're going to do on site. They do have a full-time project site superintendent, they have a full-time project manager, they have safety representatives, they have environmental representatives, and they're embedded with you. They work with you, they're on site every day. So we hand in our notifications, our containments are set up, obviously the utilities that run those containments for our negative errors. Here's some of the volumes of asbestos we ran into. And the challenge I mentioned earlier is right here, the precipitators. So the admin building, a little different, plaster and drywall, some mastic on the ductwork inside, and that's That's this building right over here. So that was a bit of a new thing for us, a little different, a little out of the ordinary. But your precipitators in particular, these mechanical collectors, so there was a mastic coating up on here, and unique to this power plant, and again, leading to that footprint that's very, very condensed, is the fact that these precipitators are on top of the boiler roof. So a little different, not something you see very often. And because we're at the World Demolition Awards and not the World Abatement Awards, we're going to kind of skip the rest of the abatement and keep going with the demo. So now we mobilize our manpower. We're finishing up our asbestos. We're trying to work our footprint back into this power block itself right here. Again, part of the mechanical collectors up top, and this is the last I'll mention about the asbestos, putting any machinery up top, our man lifts, our bobcats to help facilitate some of that. Again, just got to back that all up with the engineering for this particular client. It's a good practice anyway, but again, it's just that approval of the plans that could hold up your operations if that's not done ahead of time, if you're not constantly looking forward. For the abatement, we actually set up 4 large containments in here. Obviously concentrating on the turbine hall first because that's where our demo plans were leading next. So here we have our not our environmental, but our marine work, what we would say. So 300-ton crane came in. We picked down these barge unloaders. Very methodically went through and cleared off the mooring cells and started our demolition of some of the out areas and pulling up some of that concrete to try and get a little bit ahead on crushing of the concrete and just reducing our footprint and bringing everything into the center. So again, the demolition of the outbuildings, and now we're starting on the interior as well. Our focus, here we go again. So you could see, I didn't have a great picture of it, but you could see the switch yard next to the turbine hall. So that was the first area that was demoed, and now we're creating some space in here. So our access and egress is right in here. We have our scale set up here so we can load out scrap, check for any T-norm material, make sure we're legal weight-wise, going out this way. Because this wastewater treatment plant was saved, this here, if you go back to the engineered plans, this was highlighted as an engineered plan, and that's because this is pickwork here. So this 30-foot tall ductwork, we had to pick all that down because we're going to save this area, this structure right under here, the water treatment building. And what we want to do is start isolating again. We're getting back to this power block, and we're trying to bring everything into the center because there's obviously a lot of protection that's going to be set up along here to facilitate the implosion of the boilers. We did decide to do everything in one day, and we'll get to that in a little bit. So asbestos is cleared in the turbine hall. We certified the overhead crane. We use that for as long as we can to help facilitate the removal of the turbines. You can see, and if you've done turbines before, it's really a fascinating part of our demolition because of the size of the turbines. It really is quite a sight to sit and watch them dismantle this. The nice part is, because obviously it's demolition and we're not saving any of it, if you get to an area where, even if you can't reach it with the overhead crane, you can make a lot of pre-cuts in here, and then once you walk your machines in, now you have a large machine, you can handle it. You're not fighting it with the overhead crane or with smaller machines or having to cut it into 2 smaller pieces. So we've already made our ramp to come down into the basement on that far side. We can walk down there with our larger machines. You can see we can start working on the turbine pedestals, which are an endeavor all by themselves. I swear we go through a hammer every time we do one of the turbine bases. It's pretty substantial. I always joke, I think everybody's brother-in-law owned the concrete business, when they built it, because they pour extra, I swear. So now we want to clear the basement, because what does that do for us? We clear this entire turbine hall because now that's where the boilers are going to go, right? We're starting to implement our engineered plan for the implosion of all 10 boilers at once. We're going to roll them right into that section of the turbine hall, but to do that, we have to give it somewhere to go. So we have to empty not only the turbine hall, but now we have to empty underneath the boilers as well. So you can see our ramp right here. So that gets us in and allows us to clear everything out of the basement, which you've seen in the previous slide. It's pretty empty. It's substantially clean. You can actually see underneath here a little bit. So now we're going to start taking this turbine hall down, again, to facilitate that rolling over the boilers into the basement itself. I don't know if you can see it on this slide. It's probably the next one. It's a little bit. So the way this was built, you'll get a double column right here. So every 2 units has a double column. So we were able to take 2 units, 2 bays of this at one time. And a slight adjustment to the plan as we did this, and we'll see it in a later slide, but we realized after this next section that we could leave this exterior wall. And it just gave us a little bit more protection when it came to the actual date of the implosion. So we were able to leave a lot of this turbine wall from that 6th unit on. We've taken 4 units of the turbine hall down. We left the other 6 and tarped that just as a little more protection for the switchyard once we got to the implosion. So now we're underneath. We're creating the space for that structure to roll over. We're taking care of any hanging material. We're cleaning everything up because we have to set the charges. We have to put the box throughout it. We have to wrap it and start implementing the implosion plan itself. Now, with the structures that we're maintaining, you can see this is almost a project in and of itself as far as protection goes. And I know, I think MacGyver is actually a Canadian series, right, TV series. There are no better MacGyvers than the demolition industry workers. These, I believe, are condenser doors. They're protecting utility pits. These large motors are used as tiebacks for the overseas boxes, so they're quite industrious with the material from the buildings. Triple stacked and pinned overseas containers right next to the water treatment building. Again, this is a pit. We actually bridged beams over some material on top of that to protect this, to contain the blast and some of the fly here. These are, we actually sank telephone poles, wire rope and tarp up in here for the protection of the switchyard. You can see just panned out a little bit more, so you can see a little more protection following along here. It's pretty close by. We have this small window to drop this, so again, extensive protections, tiebacks, and some weights to hold down those boxes so that the air blast doesn't actually send them anywhere. So here's the overhead view as we're totally prepared. What I really didn't have a great picture of, and it's difficult to get a handle on for scale. So obviously we were able to leave the turbine wall here that's tarped, but this is a windrow of crushed concrete that's approximately 30 feet tall. So not only do we have this wall here, we have another 30-foot tall of stone stockpiled windrowed to also protect the switchyard from any debris. So we come to the day of, and this is the big event, and then you hand the keys over to the implosion contractor, so you have no control over it. You can see the darker areas. This is wet here. We have some dust bosses here to contain any engineering controls we can implement and still keep out of the line of fire. We've done. So we did have ASI model the stack, and Dicon was the subcontractor we used for the implosion. So here we go the day of. So very successful, everything landed in a hole. And here's an overhead shot of the same thing. And you could actually see how this turbine wall helped hold back some of that dust from getting to the switchyard. So it was a very good day. Everything landed where it was supposed to. So this is your view from the base of the stack. It almost looked like the stack kind of chopped a cruise ship right in half is kind of what it looked like on site the day of, you know. And just for scale, this is some of the crew that was there this morning standing. It's about the 100-foot mark, 120-foot mark up on the stack, which is now on the ground, obviously. So a couple of mobile crushers. Didn't have a great picture of that, but it was very, again, setting the table to be efficient. We had a couple of crushers feeding into the basement from both sides. We had stockpiled concrete previously on both sides, cleaned that, and it was ready to go in the crusher. So it really facilitated a very efficient operation once we got through getting that stack off of the structure. It was, I don't know if we could do it differently, if we would do it differently, because if you're going to do it differently, now you're moving your timeline and your general conditions out further by not having the event all done in one day. It would allow you to process material as you go, more than just one big event. However, there wasn't a real good way to do that stack. If you wanted to roll the boilers and then clean that up and then shoot the stack again, you're just kind of extending your general conditions. So, so we think it was the most efficient way of doing it. It was more difficult to clean up than we had anticipated, how everything was so condensed underneath that stack. So that was a bit of a challenge. So we had to bring a couple extra machines there to help with that. So here's a listing of our machines. Site looks great. But 17 excavators, a couple of smaller ones, they had the magnets on them, but you know, here's your main drivers that handle the scrap, the concrete. We had a couple larger ones that we needed to help facilitate getting things out of the hole when we were wrecking the ductwork, that type of stuff. So some of your larger machines definitely facilitated with that. But you can kind of see, one thing I will say is the owner's always been very, very proactive with our equipment. We have some of the best demo equipment in the industry and a lot of it. So, so we don't hesitate to use it, as you can see on how much equipment we had on there. So back to slide number 7, which I said was the inflection point really for the job, and that's where you make all your decisions on where you're going to be 18 months, 2 years down the road. That is the most important slide for this particular project. It's the second most important one for the company. The most important one for the company is this one, because once we finished Johnsonville, this was the next project we were awarded by TVA. So this is Plant Allen in Memphis, which we are currently working at for that. So thank you for your time. That is my presentation. Take any questions?
Challenging projects. I'm sure the audience has questions. If we could get the microphones out. Any questions?
Thank you.
Right here.
You have a mic?
Come on its way.
Thank you. Thank you. My question. Sure.
No, it's not. It's not on. Yeah, get him.
Yes, my question, Dennis, is on power plant work, like what we've just watched your presentation on. Does Brandenburg, being very familiar with power plants, do you have a formula for working out your iron and steel tonnage related to the megawatt capacity of a power plant?
So, great question, David. We don't, and what is it? Yeah, I'll steer everybody wrong here. No, I won't lie. Now, we've looked at it historically, so we have a lot of historical data. We've probably done 70 power plants, 75 power plants. So we have a lot of historical data, but we haven't been able to correlate it to the megawatts, right? We're more, I think we're more comfortable with the footprint and the height of the building than we are with the megawatts, because we've seen it very different, depending on I guess, the original construction of that material. So Because of the historical data we have in our database, we can be very accurate in terms of how much ferrous, non-ferrous total tonnage is there. I think we've done a good job of being able to break that down. But honestly, it's more based on height, footprint of structure than it is on megawatt.
Yeah, would I be anywhere close to saying that what we just witnessed there was a 60,000 ton job?
You would be 60% off, or 40% off. A little over 100,000 tons of steel, less than 101. So literally just over 100,000 tons.
Okay, that was one way of getting the answer from you. Thank you very much.
Any other questions from the audience?
What vibrations, how did you get on with the vibrations with the switch yard next door? Because we're doing one at the moment and they're giving us a bit of grief about it.
I'm sorry, Peter, I didn't, it's concerned with vibrations for the switchyard?
Yeah, so when you did the implosions, how did the vibrations?
We stayed below the permissible limits, I can tell you that, and so when we do that, obviously we have vibration monitors set up, and TVA gave us the parameters of what their needs were in that switchyard. We didn't have to dig any utility or isolation trenches or any dampening measures at all, so we were good to go. And I think a lot of that had to do with the fact that we dropped it in the hole and on the structure, as opposed to flat ground where that vibration can transfer.
One last question from the audience. All right, perfect. Thank you very, very much.
Thank you.
That was an excellent presentation.